Okay, still in chapter 3, hypothesis testing. So 3.6, hypothesis testing for population variance. So now you want to conduct hypothesis testing for 1 sigma square. Okay, so population variance is sigma square. Test the population variance and standard deviation. So you can also test the standard deviation because of standard deviation is the square root of variance. So recall back, sigma is standard deviation, sigma square is variance. Okay, how to formulate the hypothesis? Formulate the hypothesis for this one is hypothesis H null H1. So we put here. H null now is no longer pi, is no longer the symbol, the notation now is no longer mu, is no longer pi. The notation now is sigma square for variance or sigma for standard deviation for the left hand side. For the right hand side will be the sigma naught square. Don't put the sigma naught square, put the value. Value you can find from the equation. At the center here will be the symbol. So two-tailed test as usual, not equal H1, right tail H1 greater than, left tail H1 less than. Okay, notice here the decision or rejection, your chapter 3 here is no longer a normal distribution. So here we have a chi-square test skewed to the right. Okay, your data now is no longer symmetrical. Your data now is skewed to the right. So it is no longer symmetry. It is no longer alpha over 2 put negative and positive sign. You will have a skewed to the right plot, skewed to the right distribution. Okay, so the test statistic, like in your confidence interval, you will not use the Z or T because Z or T is a symmetrical, bell shape, a normal distribution. Now you will have a chi-square test. So here, okay, chi-square test is given by n minus 1 times s squared. What is s squared? S squared is sample variance. N minus 1 times s squared over sigma square naught. Sigma square naught is the value of population variance. Okay, so look at example. Example 3.8. Listed waiting times in minutes of customers at a bank. What is the variable? The variable is waiting time. The management will open more teller windows if the standard deviation of waiting time is at least 0.9 minutes. Is there enough evidence to open more teller windows at alpha 0.01? So the keyword here is it will open more teller if standard deviation sigma at least greater than and equals to 0.9. Okay, this is the claim. So you put the claim here. Greater than and equals will be your H1. Okay. So why do we have square here? Because this one is standard deviation. Put into variance. You will get the square. So H null H1. How many sample? 1, 2, 3, 4, 5, 6. N equals to 6. So from this data, put it into your calculator. We will have the X bar and the S. Okay, this X bar and the S. Okay, the test statistic, chi-square test is equals to n minus 1 times s square over sigma square naught. Okay, n is 6 minus 1. Alright, you will get the chi-square test is 1.1520. So look at here for the hypothesis testing 1 sigma for the left hand side and the right hand side. Look at here. Okay, for the left hand side, because you have two tail, left hand side here is chi-square 1 minus alpha over 2 nu. For the right hand side, positive right hand side here, it is chi-square alpha over 2 nu. For the two tail case, right? For the right tail, only at the right shaded region, and chi-square alpha, no. Alpha not divided by 2 because only one tail. For the left tail shaded region at the left here, you will have chi-square 1 minus alpha, no. Alpha not divided by 2 because of one tail. Okay, recall back. If it is a two-tail, you have two shaded region. So this one is chi-square alpha over 2, no. Here is 1 minus alpha over 2, no. If it is a right tail, shaded region at the right, it is chi-square alpha, no. If it is a left tail, shaded region at the left, chi-square 1 minus alpha over 2, no. Okay, for this question, it is a left tail. Okay, less than, so left tail is chi-square 1 minus alpha, no. Sorry, here is 1 minus alpha. Okay, so our alpha is 0.01, no is n minus 1, 6 minus 1 is 5. So chi-square 1 minus 0.015. 1 minus 0.01, you will get chi-square 0.99, no is 5. So here, so look at your stat table. Alpha 0.99 and the no is 5, you will get 0.5543. So you put here 0.5543. Okay, so my chi-square test is 1.1520. So where is it located at? It is greater than 0.5543. So 1.1520 is here, located at the acceptance region. So you have to read acceptance region, you have to accept H null. So at alpha 0.01, you accept H null. So here, you accept H null, you accept the claim, you support the claim. There is enough evidence to support the claim. Okay, exercise 3.6, number 1. A cigarette manufacturer wishes to test the claim that, where's the claim? The claim that the variance of nicotine content of its cigarette is 0.644. Variance is sigma square is 0.644. This is the claim. Okay, the nicotine content is assumed to be normally distributed. A sample of 20 cigarettes is randomly selected and it is found that the standard deviation is 1.75 milligram. Is there enough evidence to reject the manufacturer's claim? So what is the hypothesis? H null, H1. So the claim is here. So H null sigma square equals to 0.644. This is the claim. So sigma square is not equals to 0.644. Okay, step number 2, the chi-square test equals to n minus 1, n is 20. 20 minus 1 times s square, 1.75 square, divided by sigma square naught, 0.644. Okay, put it into your calculator, you will get the chi-square test is equals to 90.3533. Okay, step number 3, one tail or two tail. This is a two tail. Okay, you have two-sided. So chi-square 1 minus alpha over 2 nu and chi-square alpha over 2 nu. Find one by one. So chi-square alpha is not given. So alpha is 0.05. Alpha divided by 2, 0.025. So 1 minus alpha over 2, 0.975. So chi-square left hand side 0.975. Nu is 19 for the left hand side. Okay, for the right is chi-square 0.02519 for the right. So find it in your stat table. So my answer is 8.9065 for the right, 32.8523. And then you draw. Wow. Skewed to the right. Shaded region two-sided. Okay, left is 8.9065. Right is 32.8523. Okay, so now reject or accept H null. 90.3533. Where is it located? Is it in the rejection region or accepted region? So 90.3533 is here. Is greater than 32. So we reject H null. Since chi-square test is equals to 90.533 greater than chi-square 0.02519 32.8523, reject H null. Okay, what will happen if you reject H null? Okay, now you reject H null. Oh, you reject the claim. Did you support the claim? No. So at alpha 0.05, there is not enough evidence to support the claim. So you reject the manufacturer's claim. Okay, done for number 1. Number 2. The hospital administrator believes that the standard deviation of the number of people using outpatient surgery per day is greater than 8. So believe that this is the claim. The claim said that the standard deviation is greater than 8. This is the claim. A random sample of 15 days of recorded number of outpatient surgery is selected with the standard deviation of 11.2. Is there enough evidence to support the administrator claim at 1% significant level? So this is straightforward. Okay, straightforward question. This is the claim. H0 or H1? Greater than is H1. So sigma square greater than 64. Convert into variance. So here sigma square less than 64. Step number 1. Okay, step number 2. Chi square test is equals to 15 minus 1 times s square 11.2 square over sigma naught square 64 equals to 27.44. Okay, step number 3. One tail or two tail? One. Right or left? Right. Right tail, chi square, alpha, nu. Okay, chi square 0.01, nu is 15 minus 1 is 14. Chi square 0.01, nu is 14. Look at your stat table, you get 29.1412. So, right? So, right shaded here, you get 29.1412. So, reject or accept H null. 27.44 located here at the unshaded region. So, step number 4. Since chi-square test is 27.44 less than chi-square 0.0114, accept H null. Okay, what happened if you accept H null? You reject this claim, you accept this H null. So at alpha 0.01, there is not enough evidence to support the claim that the standard deviation is greater than 8. Okay, number 3 here, you will do it on yourself. I will just give you the guidance. In a wood cutting process to produce rulers, the variance of ruler's height is set to be equal to 2 centimeter at all time. So variance is equal to 2 at all time. Okay, if the variance of ruler's height is not equals to 2, the process will stop. So if the variance not equals to 2, it will stop the process. The height for a sample of 10 rulers give this data. Can we stop the process at 0.1 significant level? Okay, you have to test. So this is the hypothesis. H null, H1, sigma square not equals to 2. Stop the process. Sigma square equals to 2. Okay, the rest of it, I think you can proceed on yourself.